Good day, everyone. Welcome to our new session about Earth science. In the last meeting, we had tackled the rock cycle and igneous rocks. We learned to classify igneous rocks by their composition and texture. So today, we will discuss the other type of rock, the sedimentary rocks. Okay, so what can sedimentary rocks tells us? Sedimentary rocks tells us about paleoclimate environment, source material, history of transport and deposition, climate or temperature, and fossils. Okay, so there are two primary steps in the transformation of existing rocks into sedimentary rocks. These are weathering and erosion. The remaining steps in the formation of sedimentary rocks are transportation, deposition, burial, and latification. Okay. Transportation is the movement of sediments or dissolved ions from the site of erosion to a site of deposition. This can be by wind, flowing water, glacial ice, or mass movement down a slope. Deposition takes place where the condition change enough so that sediments being transported can no longer be transported. Burial occurs when more sediments are piled onto existing sediments and layers formed earlier are covered and compacted. Latification is what happens at depths of hundreds to thousands of meters when those compacted sediments become cemented together to form solid sedimentary rock. Two degree of sorting. We have here a well-sorted sand and poorly sorted sand. Okay, so a clast is a fragment of rock or mineral, ranging in size from less than a micron, too small to see, to as big as an apartment block. Most sand-sized clasts are made of quartz because quartz is more resistant to weathering than any other common mineral. Many of the clasts that are smaller than sand size are made of clay minerals. So most clasts are larger than sand size, greater than 2 millimeters, are actual fragments of rock. And commonly, this might be fine-grained rock like basalt or andesite. Or if they are bigger, coarse-grained rock like granite or gneiss. Okay, sorting is a measure of how similar grains, sizes are within a sediment or rock and tells us about the relative strength of the current before it is being deposited. The larger and denser grains fall faster than the smaller grains. Thus, size determines its settling velocity. Okay, so clasts within streams are moved in several different ways. Okay, so large bed load clasts are pushed by traction or bounce along the bottom by saltation, while smaller clasts are suspended in the water and kept there by the turbulence of the flow. As the flow velocity changes, different size clasts may be either incorporated into the flow or deposited on the bottom. At various places along a river, there are always some clasts being deposited, some staying where they are, and some being eroded and transported. This changes over time as the discharge of the river changes in response to changing weather conditions. So other sediments, transportation media such as waves and ocean currents and wind operate under similar principles. So with flow velocity as the key underlying factor that controls transportation and deposition. So this means that the bigger and larger the clast or sediments, the higher the energy it is needed to transport it. Okay, so the difference in the size of the clast can determine the time it has been transported. The more angular the clast or the shorter the distance it traveled. And the longer the clast traveled from one area to another, the more it will change shape into a rounder and smaller clast. Okay? Next, we have the lithification process. Lithification is the term used to describe a number of different processes that take place within a deposit of sediment to turn it into solid rock. One of these processes is burial by other sediments, which leads to compaction of the material and removal of some of the intervening water and air. After this stage, the individual clasts are touching one another. Cementation is the process of crystallization of minerals within the pores between the small clasts and especially at the points of contact between clasts. Depending on the pressure, temperature, and chemical conditions. These crystals might include a range of minerals, the common ones being calcite, hematite, quartz, and clay minerals. Compaction, it is a volume loss, mechanical squeezing accompanied by dewatering. So water lost by physical or physical means. Thus, changing its mineral composition by chemical procedure with heat and fluids. Cementation is the physical aspects. Okay, so if a sediment eventually becomes a rock, we can say it is lithified. So therefore, lithification turns sediments into solid rock, and it involves the compaction of sediments and then the cementation of grains by minerals that precipitate from groundwater in the spaces between these grains. Okay, so we have here quartz sand grains and calcite cement. Sedimentary rocks are likely to form in areas such as deltas, beaches, rivers, glaciers, sand dunes, shallow seas, and deep oceans. Okay, so in this picture, we can see the sedimentary environment. So from the geographic location and plate tectonic setting, the transport agent and medium, organic processes and organisms that modify sediments and climate. Also, we have the sediments deposited. Okay, so and also we have the continental environments, shoreline environments, and marine environments. Okay, so there are three basic categories of sedimentary rocks. Okay, the clastic, the crystalline or chemical, and bioclastic or organic. Clastic, the rock fragments are lithified or glued together to form a rock. So these rocks are made of different pieces stuck together. So conglomerate and breccia have the largest particles. Next, the crystalline rocks that form from ions or smallest particles that were dissolved in the sea water. These rocks usually form as the ocean water evaporates away and leaves the dissolved minerals behind. Okay, so these are also monomineralic. Next, we have the bioclastic organic. So rocks form from biological products. So things that died and solidified together over time. So coal and limestones are great examples. So clastic, clast, and crystalline chemical ions in solution, and bioclastic is bioorganic. Okay. Sedimentary rocks that are made up of clast are called clastic sedimentary rocks. So a comparable term is detrital sedimentary rocks. So whereas clastic sedimentary rocks are dominated by components that have been transported as solid clast. So clay, salt, sand, and etc. So clastic sedimentary rocks made of broken pieces of rocks or sediments. Okay, so for example, we have here sandstone, siltstone, breccia, and conglomerate. Next, chemical sedimentary rocks are chemical minerals dissolved in lakes, seas, or underground water. So chemical sedimentary rocks are dominated by components that have been transported as ions in solution. There is some overlap between the two because almost all clastic sedimentary rocks contain cement formed from dissolved ions. And many chemical sedimentary rocks include some clast. Since ions can stay in solution for tens of thousands of years and can travel for tens of thousands of kilometers, so it is virtually impossible to relate chemical sediments back to their source rocks. So the most common chemical sedimentary rock by far is limestone. Others include chert, banded iron formation, and evaporites. Biological processes are important in the formation of some chemical sedimentary rocks, especially limestone and chert. For example, limestone is made up of almost entirely of fragments of marine organisms that manufacture calcite for their shells and other hard parts. And most chert includes at least some of the silica tests of tiny marine organisms such as diatoms and radiolarians. So for example, we have here the Bonneville Salt Flats in Utah. So next, organic sedimentary rocks. So organic are remains of plants and animals that are deposited in thick layers. For example, we have here coal, fossiliferous limestone, and coquina. So we have here a derivation of sedimentary rocks, so from sediments to sedimentary rocks. So for example, we have here sediments of gravel. So to sedimentary rocks, may mo siyang conglomerate, sand, may mo siyang sandstone, salt to saltstone, and clay to shell. Okay, so also we have here the summary of sedimentary rocks. So detrital or inorganic land-derived sedimentary rocks. So Clastic rock formed from compacted organic matter. Okay. So structures and formations seen in sedimentary rocks includes the following. So stratification, crust bedding, graded bedding, ripple marks, mud cracks, fossils, and bio-turbation. So in the next slide, we will discuss it one by one. First, stratification. It is a series of visible layers within a rock, so most common sedimentary structure. Okay. So next, the crust bedding, series of thin inclined layers within a horizontal bed of rock, which is common in sandstone. Next, graded bedding, progressive change in grain size from bottom to top of a bed. So, muna siya ang sequence. The graph of graded bedding. Okay, so sequence above, floodplain, mud and salt, one sequence, shallow channel, fine grained sand to this part, small scale cross bedding, and the deep channel kay coarse grain sediments, large scale cross bedding. So this is the picture, the photograph, and the interpretive drawing. Okay. Next, we have the ripple marks. So small ridges form in surface of sediment layer by moving wind or water. Next, mud cracks. When clay rich sediments dry, they shrink and crack into polygonal patterns bounded by fractures. Okay, next we have fossils. traces of plants or animals preserved in a sedimentary rock, as what can you see in the picture. Next, bio-turbation. Biogenic sedimentary structures include tracks, burrows, trails, called trace fossils. So, extensive burrowing by organisms is called bio-turbation. So, it may alter sediments so thoroughly that other structures are disrupted or destroyed. Okay, so here are some examples of structures of sedimentary rock. And formation that's seen in sedimentary rocks. Again, so this is here are some pictures of the structures and formations that's seen in sedimentary rocks. Okay, this one. Okay, so that sums up everything. So I hope, class, you have learned something new from the discussion today. And yeah, see you in the next video. And God bless everyone. Have a great day.